Let's start our discussion of memory by thinking about this question that's on the slide. Do you have good memory? How is your memory? Is it good? Can you remember what you need to remember? Chances are many of you probably said no to those questions, or you may have said something like, well, it depends on what it is, what type of material it is, or something like that. But I would argue that you probably have better memory than you think you do. It's just a matter of how you're using your memory, and that you may not be using your memory very effectively or very efficiently. So as we talk about memory, we're going to talk a little bit about how memory works so that you can learn to use it more effectively and more efficiently. Now, as we talk about memory over the next little bit, I'm going to ask you to do a number of tasks. And for these tasks, you're going to need a piece of paper, so that it can be a scrap sheet of paper or something like that. So go ahead and grab a scrap sheet of paper. If you need to pause the video and do that, go ahead and get it. You're going to need a scrap sheet of paper and something to write with. And when you have that, I want you to go ahead and number your paper from 1 to 30. In just a couple of minutes, I'm going to read aloud a list of words to you, and I want you to make a judgment about each of these words. And the letter that precedes the word will tell you what kind of judgment I want you to make. So, I know at this point that may not seem very clear, but it will be in just a minute. So before I say each word, I will say the number, so you can keep up with that on your paper. And then I'll say a letter, either A or B. If I say the letter A before I say the word, then the judgment you need to make is about how many syllables are in that word. So for example, if I were to say number 1, sweater, you would make a determination about how many syllables are in the word sweater, and that's what you would write down on your paper, the number of syllables that are in the word sweater. You would put that out beside number 1. But if I say B before I say the word, the judgment you need to make is whether that word is pleasant or unpleasant. So if I were to say number 1, B, sweater, then you make a determination, is the word sweater pleasant or unpleasant? And then on your paper, out beside number 1, you would write either a P or a U for pleasant or unpleasant, depending on which you think it is. Okay, here we go. Let's get started. Number 1, A, bike. Number 2, B, month. Number 3, A, magic. Number 4, B, foot. Number 5, A, monkey. Number 6, B, clock. Number 7, B, paint. Number 8, B, bureau. Number 9, A, bird. Number 10, A, lemon. Number 11, B, fire. Number 12, B, trail. Number 13, A, soap. Number 14, B, pocket. Number 15, A, pencil. Number 16, B, train. Number 17, A, grass. Number 18, A, story. Number 19, B, belt. Number 20, A, kitchen. Number 21, B, trunk. Number 22, A, coal. Number 23, B, pipe. Number 24, A, pitch. Number 25, B, coin. Number 26, A, hammer. Number 27, A, door. Number 28, B, church. Number 29, B, travel. And number 30, A, fish. Okay, now somewhere on your paper, I want you to write down as many state capitals as you can think of. You don't have to include the state, just write down as many state capitals as you can think of. Anywhere on your paper, it doesn't matter where. So take just a few seconds to do that. Okay, actually you can stop that now. That was really just a distractor task to get your mind off of what we had been doing. Now what I want you to do is somewhere on your paper, I want you to write as many of the words that I read to you as you can remember. So they don't have to be in a certain order. You don't have to remember what letter they went with. Just the words that you can remember. Jot those down. And you may want to go ahead and pause the video while you do that. And when you're ready to continue, you can unpause. And you can check yourself to see how you did. So these are the words that I read to you a few minutes ago. So go look at your list, and for any of these words that you remembered on your list, out beside it, write whether it was an A word or a B word. And then get a tally of how many A words you remembered and how many B words you remembered. And again, you may want to pause the video while you do that, and then after you get your tallies, you can start the video again. So as you look at your tallies, how many, or which did you remember more of? Did you remember more A words or more B words from that list? Chances are some of you may have remembered more A words, but many of you may have remembered more B words than A words. So you can, again, pause the video, take a minute and think about that. That's often the way it works. People typically remember more B words than A words. We will have some people that remember more A words, but for the most part, people tend to remember more B words than A words. So you can think about why that might be the case. And I'll go ahead and tell you that this is sort of our first lesson about memory today. And it's what we call levels of processing. The idea is the more deeply you process information, the better able you will be to remember that information. And when you did that task, you were trying to determine for the A words, how many syllables there were, and for the B words, whether they were pleasant or unpleasant. To determine how many syllables are in a word, you really don't have to think about that word very much. You don't have to process that word at a very deep level. You just have to hear it and make that determination. But to make a determination about whether a word is pleasant or unpleasant, that's a little different. That takes a little bit more time. You have to think about it a little bit, and you have to process it at least a slightly deeper level. So that's the reason people often remember more B words than A words, because they process those B words a little bit more in trying to make that determination about whether those B words are pleasant or unpleasant. So that's something to think about. Maybe jot down a note. First lesson of memory, depth of processing. And depth of processing is something that you will hear about in those Stephen Chew videos that you're watching if you haven't heard that already in those. So today we're going to talk a little bit about memory in this video, and we're going to look at what we call the processes of memory. There are three basic processes of memory: encoding, storage, and retrieval. And as you think about those terms or think about those processes, you might think, is there another area where we use those terms? When we're talking about something in another field, do we use those terms? In particular, I think the word encoding, but the others as well. It's just that storage and retrieval you often hear in other contexts, but encoding, there's probably only one or just a few contexts in which you hear that word other than in talking about memory. So you may have already guessed that I'm talking about computers. When we talk about computers and how computers work and some of the things that we do with computers, we often use those terms: encoding, storage, and retrieval. And when we talk about memory, we're going to use those terms because our approach to memory is going to be what we call an information processing approach. Cognitive psychologists for a while have been using the way computers work and some of the things that we do with computers as sort of a metaphor for memory and how our memories work. And they suggest that much like computers are information processors, humans are also information processors. So they use those terms: encoding, storage, and retrieval, and those terms are the processes of memory. So with memory, we have those three processes, but we have another three. In the information processing model of memory, there are three parts. You can think of them as three stages in the memory process, but we often use parts because stages imply things are going one way. And for part of that information processing and memory, things are going one way or in one direction, but there's a part where things go in two different directions. So it's not like you're progressing from one stage to the next and to the next, and then that's it. It's really more a matter of you progress from one stage to the next, but sometimes you pull information from that third back to the second. So you can think about them as stages or parts. And so the three parts of the information processing model, or the three parts of memory according to the information processing model, are sensory memory, short-term, or what now we more often refer to as working memory, and finally long-term memory. So those are the three different parts. And we can think about those first two parts in terms of stages. Information first comes into our memory system through sensory memory because it comes in through our senses. And then if we process that information, if we do something more with that information, then it gets passed on to the second part, or the second stage, what we now typically refer to as working memory. And working memory consists of everything that you are working with at a given time. So working memory is really the same thing as consciousness. It's what you're aware of right now, everything that you can hold in mind at a given time, or that you are holding in mind at a given time. Now, when you think about what's in our working memory, or again, the other term for it is short-term memory, some of that information we want to get into the third stage, or the third part, what we call long-term memory. And long-term memory is the more permanent storage place for information. So when we have information in our working memory that we want to get into long-term memory, we have to process it in some way. And we're going to talk a little bit today about how we process it to get it from working memory into long-term memory. But the other thing that's important to know here is that when we need to use that information, we retrieve it from our long-term memory and pull it back to our working memory so that we can use that information. For example, when you get ready to take your next exam in Psych 150, hopefully you will have committed all of that stuff about learning classical and operant conditioning to memory, and it's in your long-term memory. But when you get that exam and you start reading the questions, in order to answer those questions, you need to retrieve that information from long-term memory and pull it back into short-term memory so that you can use it in order to answer the questions on the exam. So we're going to look at those three different parts or those three different components, and we're going to look at it in terms of those three processes: encoding, storage, and retrieval. So to start with, actually, I want to mention this, but we're going to come back to this. This is a little diagram of that information processing model of memory that was developed by our friend Stephen Chu that you've been getting to know through those videos this semester. And so in his diagram, you see he's got the three parts: sensory memory, working memory, and long-term memory. But he has also identified some choke points and pitfalls, things that can happen at different points in that memory process to make it difficult or impossible for us to hold on to stuff or commit it to long-term memory. And then he also identifies several different solutions for those pitfalls and choke points. So we're going to come back to that later, and I will make a copy of this available to you as well. But to start with, we're going to talk a little bit about encoding and the two basic types of encoding and the different types of memories that result when we use these different types of encoding. There are two basic types of encoding, what we call automatic processing and effortful processing. So encoding occurs through those two types of processing. And those two types of processing lead to different types of memories. So in addition to making a distinction between automatic processing and effortful processing, we also make a distinction between implicit memories and explicit memories. Implicit memories are those memories that result from automatic processing. So implicit memories are memories that get into memory without any real intention or any real effort. So this is stuff that you haven't studied. It's just stuff that gets there. It gets into your memory, and then many times we retrieve that information from memory without thinking about it. It's sort of unconscious. It happens automatically. So some examples of some implicit memories are non-declarative memories like learned skills, what we also call procedural memories, and classically conditioned associations. So those learned skills, things like knowing how to grip a pencil and form letters, or knowing how to swing a tennis racket, or drive a car, or all kinds of things. Even just those very basic things in terms of movement, those rely on what we call procedural memories. But with those, many times, especially a lot of those things like walking and just general movement, it's not like we're really making an effort to retrieve that information. And so it's implicit in that sense too. It's unintentional. We want to walk and we walk. We don't have to think, okay, what do I have to do first in order to walk? Do I have to move my legs in a certain way? Are there certain things that I have to do? It's something that just happens automatically, that just happens naturally. And then those classically conditioned responses that we talked about in talking about learning, those are also considered implicit memories because they happen automatically. They're in our memory, but it's not a matter of intentionally retrieving those. It's more of an automatic process. So in addition to automatic processing and the implicit memories that come from that, we also have effortful processing. And effortful processing results in what we call explicit memories. And so explicit memories are what we also call declarative memories. So declarative memories are another term, or declarative memory is another term for explicit memory. And these include your memories for facts and experiences that you can consciously retrieve, that you can consciously pull back into working memory so that you can think about them. So when you're studying, you are making explicit memories. And unfortunately, when we study, it's not a matter of automatic processing. We have to we have to use effortful processing. So again, you might pause here and think about, what are some of the effortful processing strategies that you use as you study for your different classes? And are they different from one class to the next, depending on the subject area? So we're going to be looking at encoding, particularly through effortful processing. But as we do, we're going to take a look at those different parts of the memory process, or those different stages in memory. So because it's sort of the first stage, it's where information first enters the memory system, we're going to start with sensory memory. Now again, sensory memory is the first step because information enters the memory system through our senses. We see it, we hear it, we taste it, we touch it, we smell it, and we have a sensory memory for each of those senses. And those sensory memories are also called sensory registers. And a couple of those have been studied more than the others. It's probably not a surprise that sensory memory for visual information and sensory memory for auditory information, what you hear, those two have been studied the most. And so we have terms for those two sensory registers. For our visual sensory memory, it's what we call iconic memory. And for our auditory sensory memory, it's what we call echoic memory. Because in sensory memory, what we hold in our memory is an exact replica of what we've experienced. So in our sensory memory for visual information, we hold icons. So an exact icon of what we have seen. And in terms of auditory information, we hold echoes. So we call those iconic and echoic memory. Now the thing about sensory memory is, or a couple of things about sensory memory. First of all, in terms of capacity, how much stuff we can hold in sensory memory at one time, it's really vast. In fact, we say it's virtually unlimited. It's everything that can make its way into your senses at a given time. Now, a lot of that information we don't process any further. It just encounters our senses, so it comes into our sensory memory, but we don't process it any further. And if that's the case, it sticks around very, very briefly. It goes away really, really fast. And that's probably a good thing because there's a lot of sensory information coming in most of the time. And if we processed all of that, we would be overloaded and overwhelmed. So we tend to be selective in what we process. And the way we process is through attention. When we attend to information that has come into our senses, then that information gets passed from sensory memory into short-term or working memory. So that is what happens in between those two parts or in between those two stages. To get information from our sensory memory into our working memory, we have to attend to it. Now, chances are many of you have had this experience before. Have you ever read, say, a page or a section in your psychology book, and then you got to the end of that page or the end of that section, and you can't remember a thing that you just read? If so, it's probably a matter of a breakdown here between sensory memory and working memory. Your eyes have passed over that information, so that information has made its way into your sensory memory. But if you didn't attend to it, it never got processed and passed on into working memory. So that's the key, attention. You have to attend to it in order to get it from sensory memory into working memory. Now, first of all, there's a lot of information that comes into our senses that we really don't need to attend to. As you're watching this video, you might take a minute and just pause and see if you can pay attention to all the sounds around you. Even if you're in a pretty quiet place, there may be sounds like your heat, or maybe you're sitting close to an appliance like a refrigerator or something like that, or you could be sitting in another part of the house from, say, the washing machine or the dishwasher. But you may be able, if you listen closely, to hear those things. Even a couple of minutes ago, before you started focusing on those things, that information may have been making its way into your echoic memory. But because you weren't attending to it, that information didn't get processed and didn't get passed on to working memory. And again, that stuff you may not need to get to working memory. But when you're studying, that's when you want to get that information from sensory memory into working memory. And so the second lesson of memory today is that in order to get it, you have to attend to it. So attention is really important. Attention is key. So that next part of the memory process is, of course, short-term or working memory. Back when this information processing model of memory was first developed, back in, I think it was the late 60s, early 70s, they talked about this stage as being short-term memory. But for a lot of people, when they think of short-term memory, they think about it in relation to long-term memory. And people often mistakenly think, oh, my short-term memory is my memory for things that happened maybe yesterday as compared to a year ago. And that's what's in my long-term memory. But according to this conception of memory, or this model of memory, short-term memory is really everything that you're aware of, everything that you're conscious of, everything that you are working with. So the term working memory might be a more apt term. It's certainly a more descriptive term of what this part of the memory process involves. So it is what you're working with right now. Now, just a few minutes ago when we talked about sensory memory, we talked a little bit about capacity and the fact that the capacity of sensory memory is virtually unlimited. But what about working memory? How much stuff do you think you can hold in working memory at one time? So how much stuff can you keep in mind at one time? Well, it turns out that it's not as much as what we see with sensory memory, but to see how much it is, let's do another one of those little memory exercises I was talking about. For this memory exercise, what I'm going to do is I'm going to read off a series of digits to you, so a series of numbers. And I'll actually do several digit series or number series. And when I get to the end of a series, I want you to write down all of the numbers that you can remember from that series that you can. So don't write while I'm saying them, but when I get to the end of a series and I pause, then you should write down all the numbers that you can remember from that series. Okay? So here's your first series. 2, 8, 3, 1. You can write those down, what you can remember. All right, and here's your second series. 7, 4, 1, 3, 9. And your third number series. 4, 9, 7, 2, 1, 5. And your fourth number series. 5, 1, 8, 3, 9, 2, 6. And next one. 1, 9, 5, 6, 3, 4, 7, 2. And next, 3, 6, 2, 5, 1, 9, 7, 4, 8. Next, 6, 1, 5, 4, 9, 8, 3, 2, 8, 7. And then finally, 8, 9, 3, 1, 6, 4, 2, 7, 5, 1, 3. So let's see how you did with those. You can check yourself and see how you did. So you may need to pause for just a minute and see how many of those you got completely right. They don't have to be in the same order, but if you got all 4, 2, 8, 3, 1 in any order for the first one, give yourself a check and then do that for the others. And you can pause to check yourself. So how did you do? Chances are most of you probably remembered all 4 of that first series. Many of you probably remembered all of the letters in the second series, possibly the third series. Some of you may have even remembered all in the fourth or beyond, but there's a good chance that many of you kind of started to drop off, that maybe you missed a few as you got down to like the 4th, 5th, and 6th. That's because we were bumping up against what we call the capacity for short-term memory. And the capacity for short-term memory is what in the early days of information processing theory they used to call the magic number 7, but they have estimated that the capacity for short-term or working memory is about 7 plus or minus 2 items of information. That's about how much information you can hold in short-term memory or in working memory at a given time. So that's about what we can hold on to. And it turns out that what's in our working memory, unless we keep it there, unless we maintain it, it gets lost pretty quickly within just, seconds to a minute or two. And And so we have to do more with it to get it into long-term memory most of the time. And so we're going to talk about that in just a few minutes in terms of some effortful processing strategies. But what if, for some reason, you needed to hold more information in short-term memory at one time? Well, there's a strategy that you can use, and to talk about that strategy, we're going to first do another little exercise with your memory, and it's going to be very much like this last one that we just did, but instead of numbers, I'm going to read off a series of letters to you. So I'll read off a series of letters, and then I'll stop. When I stop, write down what you can remember, and then I'll read off another, and you'll do the same. So here we go with that one. T, J, Y, F, A, V, M, C, F, K, I, B. Okay, and here's a second one. TV, FBI, JFK, YMCA. So again, you can check and see how you did on those. My guess is that a lot of folks probably weren't able to get all of the letters in that first series, but many of you probably got all of the letters in the second series. And it turns out that there's the same number of letters in both of those. They are the exact same letters. They're in a different order, and the key difference is they are grouped or chunked together into meaningful units. And so you may have, and I tried to lead you to make use of a technique that we sometimes call chunking. And chunking is a good way to hold on to more information in working memory at a given time. It can also be used as an effortful processing strategy to get information into long-term memory, but it may not be as effective as some of these other techniques are. So that's where we are now. How do we get information from working memory into our long-term memory? Because that's really what you want to do as you're studying. You need to get information for your classes into your long-term memory so that you can find that information and retrieve it later when you need to use it. Not only to take a test, but also for other things in your career and just in life in general. So what are some of the techniques that we use? Well, these are some examples of effortful processing strategies. We have things like mnemonics, spaced study, and self-assessment. And it may be that all of those are familiar to you, but if not, mnemonics are basically memory strategies. So there are different types of mnemonics. Things like rhymes and songs are examples of mnemonics. We use rhymes and songs to help us remember all kinds of things, and that was the whole idea behind Schoolhouse Rock, and some of you may have seen some of those Schoolhouse Rock videos. But chances are you may use rhymes to remember a lot of other things too. I know anytime I get ready to write the word receive, I have to say to myself, I before E, except after C. And that's kind of the rule with I and E. There are exceptions to that, so science is an exception and there are others, but for the word receive, that rule works. And so every time, in order to remember what order to put that I and that E, I have to repeat that rhyme to myself. So you might think about some rhymes or songs that you use to help you remember things like that. Other types of mnemonics are what we call acronyms and acrostics. And you're probably very familiar with acronyms. That's when we make up a new word using the first letter in a series of words that we want to remember. Some of you may remember the colors in the spectrum using the name Roy G. Biv. Roy for red, or R for red, O for orange, Y for yellow, and so on. That would be an example of an acronym. And then acrostics are sentences that help you remember some certain things. So the first word, or the first letter in each word in the sentence, is the first letter in the word that you're trying to remember. So some of you may have heard, "My very eager mother just served us nachos." That's an acrostic that people often use to help them remember the planets. It used to be, "My very eager mother just served us 9 potatoes," when Pluto was still considered a planet, but then they had to change it when Pluto got demoted. But there are other mnemonics too. Students often remind me that the order of operations, "Please excuse my dear Aunt Sally," and there are many, many others that are pre-established like that, but you can make up your own acronyms and acrostics. A couple of other techniques, a couple of other mnemonics are what we call the method of loci and the peg word system. And if you'll take a look at the resources I have for you in the memory section in Moodle, you'll see links to websites that give you a little bit more information about those two sources. So you can take a look at those there. Now, a couple of other techniques that you're hearing about in those Stephen Chew videos and that we will talk a little bit more about are spaced study and self-assessment. You probably know, you've heard in the Stephen Chew videos that it's not a good idea to cram. Instead, it's better to spread your studying out over time. So study each subject a little bit every day. And there are a couple of reasons that that's important. Some of those we'll talk about when we talk about memory and the brain a little bit later. But the big thing is you're not rushing yourself and you're giving yourself time to repeat it. So we tend to remember things better when we have studied them over a long period of time, even if we've spent less time at each of those sessions. It's just the fact that we've kind of spread it out. And so that's what's sometimes called the spacing effect, that tendency to remember better what we have studied over time. But in addition to spaced study, that's also called spaced practice. And then self-assessment. Self-assessment relies on the testing effect. And it's what in the Stephen Chew videos you've heard as retrieval practice. And in fact, we've used that term quite a bit in class up to this point. When you test yourself, when you try to retrieve information, even if you can't retrieve it correctly, even if you don't remember correctly, you're helping to set that information into your memory. And so that's what we sometimes call the testing effect. So make use of retrieval practice and different strategies for retrieval practice. Now, another type of effortful processing strategy is making new information meaningful. Anytime we can, something that we're trying to commit to memory that's kind of new, if we can connect it to something that we already know, if we can think of an example, if we can in some way make that new information meaningful, then we're probably going to be better able to remember that information. So that's something that we're going to pick up with a little bit later. But we're going to go ahead and finish up this video by summarizing some lessons. First of all, that first lesson, depth of processing. The more deeply you process that information, the better able you will be to retrieve it later, the better it will be committed to memory. The second lesson that we talked about is attention, that you have to attend to it before you can ever get it. And then a third lesson of memory that I didn't point out as we were talking about it, but we'll take a couple of minutes to talk about it now, is related to multitasking and the capacity for working memory. The capacity of working memory is limited. We just saw 7 plus or minus 2 items of information. And when we multitask, what we're doing most of the time is we're trying to divide our attention between tasks. But the problem is when we start to divide our attention between tasks, we're spending a little bit less or giving a little bit less attention to each individual tasks. And with some things, you might be able to do that. There may be some things that you need to do that don't require a ton of attention. I know when I'm washing dishes, lots of times I am listening to an audio book or a podcast, or I'm talking to family members or something like that. And that's because I can wash dishes while doing those other things. Washing dishes doesn't take a lot of my attention at this point, and so I can multitask with that. But a lot of times we try to multitask when we're studying. We may try to watch a show on Netflix while we're studying, or have a conversation with friends while we're studying. And if we do that, we're taking attention away from a task that probably needs a lot more attention than we're giving it. Now, that's not to say that studying with other people is a bad idea. Studying with other people, as long as you're on task and you're focused on the topic and you're really paying attention to the topic and processing that information, then it's really, really good. But if you get together to study with other people and you end up doing other things, you're taking attention away. So I would say that the third lesson is that multitasking can be problematic because it interferes with what we can do in working memory. So those are kind of 3 main takeaways for today.